Here we are using the TI-83 or TI-84, whichever one it is. Any other qualifiers don't matter, whether it's, mine says TI-84 plus C Silver Edition, so mine's color and whatnot, but really, as long as it's 83 or 84, this will work the same way. So what we're going to do is calculate the mean and standard deviation of a frequency distribution. Now, very much like in Excel, we can have the calculator perform groups of calculations all at the same time, but we have to do it in a more creative way. So the calculator doesn't have a spreadsheet style thing built into it, but what it does have are lists. So there's a button here, it says Stat, and above it in blue it says List. This is where we're going to be accessing the lists in order to create or to input the values that we need. Now it's going to look a little bit like a spreadsheet, so that's good. It'll have a kind of a familiar thing going for it. So first we're going to press the Stat button, not the list menu, the Stat button. Now you'll see a menu like this come up. It might have some slight differences depending on whether you have a TI-83 or TI-84, but it's the same basic setup. And the thing we want to look at first is this top one that says Edit. So you hit Enter to select it, and what we've got here is separate lists where the calculator can store lists of values. In this case, we're going to treat it like one list is the midpoints of each class, one list is the frequency of each class, etc. So we're going to use the same example that we did in the whiteboard video. That is the drive-through times. So in this case, we don't need to have the calculator compute the midpoints. We can if we want, but it's not really necessary here. So what I'm going to do is compute the first midpoint, and type it in, and all of the subsequent midpoints as well. So that's our first column. Now we don't get the choice to label it X for midpoint, so we're just going to kind of have to keep track of that as we go. Now the other bit of information we already have is the frequencies, so I'm going to fill them in. And what we've got is something that so far looks like the frequency distribution, or at least the midpoints and the frequencies that we've had before. Now, much like in Excel, we can have the calculator take the values in the corresponding values in each list and multiply them together or perform other calculations with them as needed. So if we were to find first the mean of the distribution, we need each data value, or the midpoint of the class, times the frequency. So what we need in this list 3, is we want the first cell in list 3 to be the product of the first cell in list 1 times the first cell in list 2. The same for the second row and the third row. So we can have it do that whole thing at once if we go up to L3 and highlight that box. And at the bottom here, you'll see it says equals. Here we can actually type in something that will fill in this list here for us. So what I'm going to do is I'm going to type in L1. Now, if you look down here above the numbers 1 through 6, you'll see in blue are L1, L2, L3, L4, L5, and L6. These are references. Much like in Excel, we were able to type a column and row, the letter of the column and the number of the row to locate a specific cell. We can locate, well, in this case, an entire column or an entire list. So I'm going to type L1 times L2. And what this will do when we hit enter is it will go down the line of L1 and L2, and it will take the first of each and multiply them and put it in the first spot in L3, and the second in each and put in the second spot of L3, and so on. We can easily verify this by looking at the prior video where we had these values filled in there. Okay, now in order to add up the values in that, which is something that we would do on Excel or we would do by hand, we can have the calculator add up all the values in a list, but unlike Excel, we can't have it do it in this thing here. So that's where the similarity to a spreadsheet kind of ends. To do calculations like within a list, such as adding up all the values in a list, we actually have to go back to the main screen of the calculator. So as always, there's right here next to the second button, it's above the mode button, it says quit. So that's your way to, I guess, kind of minimize all windows, if you will, and take yourself back to the desktop or the home screen here. Now, to perform calculations with lists, that's where we're going into this list menu. So we hit second, and then the list menu. Now we have names here, meaning that rather than using the L1 that's above the 1 button, we can reference a list by going through here, but I find that to be a little bit arduous. There are times where it's necessary to do that if you were to create other lists, but if you're using the 6 built-in lists, it's probably faster when you need a reference to just use these down here. But what I am interested in are the other two submenus, the ops and the math. Specifically here, the ops. Now, there's all sorts of things here, like for whatever reason, if we needed a list to be in order, like if we needed the data, if we were looking for a median and we need the data in order, we can have the list get sorted from smallest to largest or from largest to smallest. There are numerous things here, and most of them you honestly don't need to worry about. There are some fairly advanced kind of commands that we would need we'd need the instruction book for the calculator to see the exact syntax. So we're not going to be going into anything big there. However, there is the math menu, which we would use considerably more often, where we can actually find the mean of all the values in a list if we have a list of the raw data values. The median, although when you use technology to find a median or quartiles, it tends to be, unfortunately, it tends to use an algorithm which sometimes doesn't exactly hit in the right spot. That being said, here's the sum. We can literally have it add up all of the values inside the list. So I'm going to pick that just by pressing the number 5. Now, I need to tell it which list I want to take the sum of, and that's really the only argument that we need here. So I want the sum of, because that's where we have our midpoint times frequency. So close off the parentheses, and if we hit enter, there it is. It just adds up the numbers in the list and puts it right there. Now, that should look familiar from times we've worked through this problem before. So all we have to do then is divide that by the sample size, which is the sum of the frequencies, 50. So we can just take that and divide by 50, and that will give us our sample mean for the grouped data. Now, when we did this by hand on the whiteboard, we used the rounded grouped mean of 160.0, or just 160. When I did it in Excel, I used the exact value, 160.02. And what we saw was that moving forward, using that 0.02 versus rounding it made very, very little difference in the long run. In fact, if we follow the rounding rules, we ended up with exactly the same standard deviation after rounding. Now, part of the reason that we did it that way in Excel is because we had this value stored in a cell and therefore could just reference back to it. The calculator doesn't have the capacity to do that exactly, so we will get a choice of what we want to use. I'm going to stick with this value because it has a reasonable number of decimal places. So I don't think because we're using technology, we don't have to worry about the numbers getting ugly. The only thing we have to worry about is, can we actually type them all in? And this has a short number of decimal places, so it's definitely reasonable. Okay, so that's our mean of the frequency distribution. So what I'm going to do is go back into my lists. So again, the stat button, and then the edit command. Here's our lists. Now, in order to do the standard deviation, we need to fill in a few more columns, including the deviation of each data value. So, in order to do that, I need to one by one take the midpoints of each group and find their deviations by subtracting 160.02. Now, again, I can do this by hand and fill them in, but I can also do it a little more quickly using the calculator here. What I can have this do is take the list 1 and subtract 160.02. And while that might seem odd, what this will actually do is it will, one thing at a time, go through each value in the list 1 and subtract 160.02. Then go to the next value and subtract it, and so on. We hit enter to complete it, and it will fill in the values. Again, these values should look familiar from having done this on Excel. They are not exactly the same, but should look very, very close to when we did this on the whiteboard. Now, the deviations are nice, but they always add up to 0 when we figure in their weights, that is to say, when we figure out their multiplications by the frequencies. But that being said, before we do that, we have to square them. So, once again, I want this list to go through each of these values one at a time and square them. So, all I need to do is reference list 4 and then have it square it. And again, one by one, it will go through each value in the list and square it and stick it in list 5. There they are. Now, remember that we saw this on Excel, that sometimes there's more decimal places, or the words that you're typing might be longer, and the cells in Excel were not wide enough to show all of it. So we could resize the columns so we could see the rest of the decimal places. Well, we don't have that capability on the calculator. Each column is a fixed width. So you'll notice here that while in the lists up here on the main screen, it says 3424.6. That's because it can only fit those 5 digits, so it's rounding. Only for display purposes, because while the cursor is on that value, if you look at the bottom of the screen, you can see the full list of decimal places. So keep that in mind, that what the values you're seeing up here in these lists, when it's set up in this table kind of format, might not be the exact value. There might be some more digits than you see there, and it has been rounded, or if there's enough digits that are on the left side of the decimal place, perhaps you'll even see some scientific notation. Okay, moving right along, we have, and again, we have to keep track of this because we can't rename the columns. We have the deviations, the squared deviations. Now it is time to multiply the squared deviations in list 5 by the frequencies in list 2. So we're going to take the squared deviations in list 5 multiplied by the frequencies in list 2. And it'll fill them all in. Again, with some numbers that, if they don't seem familiar, you can easily compare them to what we've come across previously. Now, this was as far as we need to go with expanding our table by adding on columns of new calculations. At this point, what we need is to add these up. So we will once again quit back to our main screen. And we need to again choose the sum, except this time it will be of list 6. So again, we press second and go into this list menu. We go to the math sub-menu, and we choose the sum. The sum of L6. And that is, again, the same value that we came upon in Excel, and, well, very nearly the same value that we produced when we did it on the whiteboard. Of course, we're not done yet. This is the sum of the squared deviations times their frequencies. We now need to divide that by 1 less than the sample size. So again, we want to make sure that subtraction happens first, so it goes in parentheses, and we hit enter. Now, we're still not done. This thing has a disgusting number of decimal places, of course, but that's okay, because this feature in the calculator, this ANS thing, always references the previous answer, so we won't have to worry about typing all this monstrosity in. What we need to do is one last step, and that's the square root, down here above the x squared button in blue. So we hit second, and then type this for the square root. Now, if we want it to reference the previous answer, like when we did it up here, all I did was I started by pressing the division, and it automatically did the ANS for me. If you need to manually put ANS somewhere else, it's down here at the bottom of the calculator above the negative button. So I'm going to hit second, ANS. And there it is. The standard deviation of the grouped data, which would round to 49.9, which again matches everything we've seen for every other way this has been done so far. So the calculator is a pretty good tool. If you do not have access to Excel, I understand that everybody has access to it through Office 365 through your MyMCC, but honestly, I have found that the web-based Office apps are very slow to use, and they do not have the full functionality. So if you want to use it, go for it. If you have the patience for it, that's great. But I wanted to have this other alternative for those of you who have the calculator but don't have Excel. Of course, if you have a Mac or an iPad, there is the Numbers spreadsheet app, which is covered in a different video, and that functions a great deal more like Excel. But the calculator's here, and it is an option for you if you've got it. The only real problem with the calculator as far as this goes is if you're doing the raw data, it really is a pain in the butt to get all that data in. I mean, with Excel, I can type it all in for you, and I can post the file with it pre-typed. If you're going to use your calculator, you need to then manually go in and type each data value. So in this drive-through data, it was 50 data values, and some of them were, they had 2 and 3 digits in each value, and that just takes a long time to type in. Now, if you can do it, you can leave the information stored in a list for as long as you want. You can even create your own lists beyond just the 6 that are built in. So I'm going to give a quick rundown for some other things you can do here. So again, I'm going to go into the Stat menu and the Edit command. So there's the 6 lists that are built in, but if we go further to the right, we have a blank list, and we get to type in a name. So if you look in green, above all these buttons are all the letters of the alphabet. We can actually name a list. We can call it data set. We could call it drive-through. If I'm not mistaken, the list names are limited to 8 characters, so you might have to be a little creative with how you abbreviate it. But we could create our own list and store the data in there and just leave it alone for as long as we want. Of course, then you actually have to type it in, which is, again, kind of annoying. But let's take a look at some other things that we can do with a list. If we do have a short list of data that's not too big of a deal to type in, there are things we can do with it, like calculate the mean very quickly. We don't actually have to type in all those values to add them. We can type them in the list and then do the mean of the list, which might not seem like it's much of an improvement, but what if we also need the standard deviation? Well, here it is. Choice number 7, the standard deviation of any list. So rather than having to type all 50 values from the drive-through times in to add them and then divide by 50, and then if we want to do the standard deviation, to have to type them all in again with their deviations and squaring the deviations and whatnot, that seems a little ridiculous. We could just type them all into a list once and then do multiple different calculations with them as we see fit. Actually, there's even a quicker way than that. I'm going to go back to the Stat button for a moment, and I'm going to go over to this Calc menu. There are a lot of things in here. Many of them have to do with regression, a topic that we do not have the time to cover, but you would see in Stats 2. What I'm interested in is this very first one up here, one variable statistics. If we select that for any list, it will give us all kinds of information, some of which you'll recognize, some of which you might not, but it would give us, say, the mean and the first and third quartiles, the median and the first and third quartiles. It would calculate the mean, the standard deviation, the variance, even a couple of things that you have not heard of and that we aren't covering. So it would give you a lot of information about that list really, really quickly without the need to do each individual command. So the calculator's got some really powerful stuff here. When you get into Stats 2, there's things over here in this Tests menu which will really be very helpful for a lot of what you do in Statistics 2. So it is still a very, very useful tool. Personally, if I have access to a desktop computer or a laptop, I would prefer to use Excel or numbers. I prefer a spreadsheet than the calculator, but if the calculator is what you've got, it certainly can get the job done. As always, though, whether it's Excel or the calculator, always double check to make sure you're typing stuff in right, because if you make a mistake and you don't realize it, your answer is going to be thrown off and you will probably never even realize it. So be very careful typing the values in, even when it's something smaller like what we did here. Even when it's just something smaller like the midpoints and the frequencies. If I make a mistake with any of these things, it's going to throw all of the rest of my work off. So I've got to make sure I type them in correctly. You can never check it too many times. Double check it, triple check it. Always make sure.